Alright, so now that we've reviewed how to make tables, take from functions, and then graph out what's in the table, we're going to come to graphing piecewise functions. Alright, now, with this, we've already talked about what piecewise functions look like. We've already evaluated them like we said in the last video. So this time, we're going to go ahead and start talking about what we just did, tables and everything. And we're going to focus on this part of the notes, focus on tables. So I'm going to put the word tables right here. So tomorrow, the next video, we'll actually talk about taking those, well, maybe the next video, we'll start about taking those video tables and making them into graphs. So we'll take a look at that. Well, not next video, but like examples, later on examples. Alright, so first off, when it comes to our piecewise functions, remember there are pieces of functions put together to make a graph or a function, but there's multiple functions, multiple equations there. So with that, the number of equations kind of helps us know how many tables you have. So you will have a table for every equation, or for each equation, in the piecewise function. So no matter how many functions there are, or equations there are inside the function, that tells you how many tables you need to have. So if you have 3 functions, you have 3 tables. If you have 2 functions, you have 2 tables. If you have 4 functions, you have 4 tables. Right? So with this, I'm going to go ahead and write out the piecewise function here. And with this, I'm going to color code it so that when we actually work things out, it's going to hopefully make more sense, or make sense. And hopefully already makes sense a little bit, but it's going to be good. Alright, so we have our piecewise function here. And here, my first one is going to be x squared plus 1 if x is less than -5. Our second function is going to be second equation is going to be x if x is between -5 and 1, including -5 and 1, including it, -5 and 1. All right, and then we have x cubed if x is greater than 1. Right, now this one is technically not an actual official example. I'm just putting this here so that we can go through the pieces of it and then actually get it all together so it makes more sense. So again, this is not actually an example, but it's kind of example. So we're going to actually start with the next example later on. But here, yeah, this is what we got going on. Alright, so if we look at it, okay, we have 3 equations going here. 1, 2, 3. 3 lines. So again, here, I'm going to write this out. We have 3 equations. Alright, so since we have 3 equations, we have to have 3 tables. So 3 equations, 3 tables. Hopefully that makes sense. 3 equations, 3 tables? Yeah. Alright, so with that, each one of these lines right here, I'm going to make a table for it. And I'm going to, again, color coordinate it. So I'm going to start off with this one first. And here I'm going to go ahead and put the value. So I get x right here. I get x squared plus 1 here. I'm going to go ahead, again, I'm going to do all of these at the same time, make the tables. This one's going to be a little bit longer, and I'll explain why that is. then this last one, it's going to match up with the first table. The same length as the first table. And again, I'll explain all this to you, like why things are happening the way they are. Execute. Alright, so we got all that happening. All that's going good. Alright, now, in all this, these conditions, these intervals, these restrictions, these domains, here, all of these right here, just like before it told us what function to actually use to evaluate, but this right here tells us the x values. To use for each table. So for each table, these numbers right here are going to tell you, but it's color coordinated. So the purple one, the first one, goes with the first table. The green one goes with the second table. The orange one goes with the third table. So let's dig deep into this. Let's look at it. So with this, I'm going to put this sticky note here, and I'm going to uncover the words later on. Our first lesson was interval notation, and we talked about graphing and be able to have everything in here. So that's what we're going to look at right now. And again, we didn't do open and close circles with the number line. But here, we have a parenthesis on 5. We know we're shading this direction because it's less than. But I also showed you guys that if x is on the left side there, that all you have to do is just make an arrow. So if x is on this left side over here, all you have to do is kind of like make this into an arrow, and it points the direction that you need to shade. So it's pointing to the left. So we shade it to the left. All right, so let me look at a different color I have here. Yeah, should work. All right, I hope. Yep, that works. All right, so looking at these numbers in the shaded area, that's -5, -6, -7, -8, and -9. So all those numbers are back there. Now, with this, what I'm going to tell you at all times is always use this actual endpoint back here. So that number that gives you right there, all these numbers, always use that in your table. And I'll explain that in a few seconds of why we have to do that. So we're going to say -5, -6, -7, -8, -9. Right? Now, one thing I'm going to say here is the reason why we're actually using that endpoint is think about this idea, or this thought process. Right? We have -5, we have -6. Right? Now, if you just automatically say we're dropping off -5 and we're going to start at -6, think about all those numbers that are missing between -5 and -6 that are still in that shaded region. So looking at here, -6 is there, -5 is there. There's still numbers between there that must be shaded in, right? Right. So that includes numbers like -5.5, -5.9, -5.6, -5.5555552. All those numbers are there. So if we actually just cut off and start at -6, that means there's so many numbers right here between -5 and -6 that's shaded right there that's not represented. So you must always start with that number right there, that end point. All right. So here, once we get to that part, I'm going to go to Desmos real quick, and I'm going to put this equation in, and I'm going to put that there into the calculator. All right. So I'm going to go ahead and come back to Desmos. I'm going to get rid of this graph right here. Oh, no. I didn't want to get rid of the whole thing. Oh, well. I deleted the whole thing. Sorry, guys. All right. So again, I'm going to go ahead and erase the things we don't need. So we don't need the x1 sub 1 or the y sub 1. So here we're going to just put x here. Going to put the function x squared plus 1. And we're going to put the x values. So -5, -6, -7, -8, -9. And with this, as you guys are putting it in and everything, if you can do it by hand, do it by hand. If you want to use a different calculator for it, do a different calculator, guys. It's perfectly fine. If you can just remember, do it in your head, that'll be even more amazing because you already know your doubles here. So hopefully you do. But I'm going to do this real quick so that way we can go ahead and keep moving forward because that's not what's being focused on right here. Test it. All right, so we got that first part. So that's going on. All right, now the next one, next table here, it has the x values from -5 to 1. Again, we're using the endpoints, and this time because it's equal to it, should make even more sense. So -5, -4, -3, -2, -1, 0, and 1. We can come back here. All right, so we have that happening. So we start at -5, we end at 1. All right, so looking at all these, it's just going over to x. So that's -5 in for x is -5, -4 in for x is -4, -3, -2, -1, 0, 1. And again, all you're doing is taking your x and you're putting that value in for x. So you -5 you put in for x, it gives you back -5, so on and so forth. If you the -5 here, -5 squared, put in for x, square that, plus 1 is 26. -5 squared is 25, plus 1 is 26. All right. Then our last one again is looking at our number line again. We know we start at 1, and we said we're going to do the numbers that are bigger than 1. So that's 2, 3, 4, 5. All right. And so if you put that into the calculator, you can go back to decimals if you want to, or I'm just going to give you the numbers. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. So you got those. All right. So as we're going to move into the next video for this next part of it, but this is the table. We made the table. So now we're going to go ahead and talk about the specifics of finishing up the tables here, because we had to talk about graphing things. All right, so let's go to that next video. I will see you then.